Welcome to an introduction to educational research. Today's video will deal with presenting some essential research vocabulary for you to become familiar with. So the objectives are to define the following essential research terms: a dependent variable, an independent variable, a confounding or extraneous variables, and then to take a look at the concept of validity in terms of internal validity of research studies and external validity. And we'll discuss and talk about the validity concepts. But first, let's start out with the dependent and independent variables. Now, have seen several times this research article about prompting bar patrons with signs to take free condoms. So let's just take a look at this in terms of dependent and independent and confounding variables. So a dependent variable is the effect in a cause and effect relationship. In other words, it's the change in behavior as a result of the application of some kind of intervention or treatment, which is actually an independent variable. But the dependent variable is the change in behavior, and it is dependent on the application of the independent variable. That's why it's called a dependent variable, because its change is dependent on an intervention or a strategy or an independent variable. And you can usually always determine the dependent variable in a research study, most of the time just by looking at the title. If you ask yourself the question, what is it that the researchers are measuring? What is it that they're measuring? No matter what it is that they're measuring, that's the dependent variable. So if you take a look up on the top, prompting bar patrons with signs to take free condoms, well, what were the researchers measuring? They were measuring the number of condoms that were taken. And so that is the dependent variable in that research study. Now, the independent variable is the intervention or the intervention strategy. It's the cause in a cause and effect relationship. It is what causes the change in the dependent variable. So if you take a look up on the title of the research article, Prompting Bar Patrons, you'll see underlined in red, prompting bar patrons with signs. So the presence or absence of signs in the bars was the independent variable. That was the independent variable. That was the strategy they were using to try and make a change in the dependent variable, which was the amount of free condoms taken. These are two important terms. If you're not familiar with them, or if they're new to you, try and get them under your belt, because they're really important in terms of your understanding research articles that you will be reading. You'll want to know what is, if any, what is the dependent variable? What are the researchers measuring? What is the independent variable? What is the treatment or treatments? And finally, in terms of variables, we have confounding or extraneous variables. And they are variables that offer alternative explanations for the change that has taken place in the dependent variable. In other words, it may not have been the intervention strategy or the independent variable. It may not have been the presence of the signs in the bars that caused the patrons to take more condoms. It may have been something else. There may have been some other variables lurking behind the scenes that the researchers were unaware of. So these are variables that can really weaken a research study because they supply alternative explanations. So these three concepts of variables: the dependent variable, which is the change, or the effect in a cause and effect relationship, and it is dependent on the independent variable, which is the treatment or the intervention strategy. You can always identify the dependent variable by asking yourself, what are the researchers measuring? And the independent variable is independent and intervention, begin with the letter I. So if you ask yourself, what's the intervention that the researchers are applying? That would be the independent variable. And then confounding or extraneous variables are variables that get in the way. They are the noise that can mess up the validity of a piece of research. Well, okay, let's take a look here. Now, on your screen are 5 titles of research articles. So I'm going to ask you to read them over. I'm going to ask you to put the video on pause, take a look at these, and write down what is the independent variable for each of them and what is the dependent variable. In other words, for number 1, the effects of least to most prompts on the ability of a student classified with autism to independently make a peanut butter sandwich. What is the independent variable in that study and what is the dependent variable? So put the video on pause, pardon me, do all five, identifying the independent and dependent, then turn the video back on and then we'll take a look at it. So go ahead. Well, okay, let's see how you did. Number 1, the effects of least to most prompts on the ability of a student classified with autism to independently make a peanut and butter sandwich. It's supposed to be peanut and butter sandwich. Okay, so what would be the independent variable there? What is the treatment? What is the intervention that the researchers are doing? And the intervention is a concept or strategy called least to most prompts. So they're using a strategy called least to most prompts. And what is the dependent variable? Well, you ask yourself, what are the researchers trying to measure here? Well, they're trying to measure the students being able to make a peanut and butter sandwich independently. So that is the dependent variable. That's what they're measuring. Let's take a look at number 2. New math instruction versus traditional mathematics instruction on the ability to learn single multiplication facts in a 3rd grade classroom. Well, what is the independent variable here? What is the treatment? Well, you might say the treatment is new math instruction versus traditional math instruction, which you would be correct. It is the type of mathematics instruction. Either it's going to be new math or traditional mathematics instruction. That is the independent variable. The dependent variable, what are the researchers measuring? They're measuring students' ability to do single multiplication facts. So that is the dependent variable. Let's take a look at number 3. The effects of interactive multimedia on the achievement of 10th grade biology students. Okay, what is the independent variable? What's the treatment here or the intervention? Well, the intervention is interactive multimedia or non-interactive multimedia. But interactive multimedia is the independent variable. And the dependent variable, what are the researchers measuring? Well, they're measuring achievement of 10th grade students. Now, they didn't say what achievement was, but they would have to operationally define whether it's test scores or whatever, but it's some type of measurement of achievement. All right, number 4, the use of response cards to teach sight word vocabulary in the kindergarten classroom. So what is the treatment here? What is the independent variable? Well, it's the use of response cards. And what are the researchers measuring? They're measuring the acquisition of sight word vocabulary. So that is the dependent variable. Let's take a look at the last one. Hand raising versus oral responding in teaching 3rd graders to spell. Okay, so what is the intervention that the researchers are applying here? Well, hand raising versus oral responding, or 2 different ways of responding, that would be the intervention. Both of those would be correct. And what is the dependent variable? What are the researchers measuring? They're measuring 3rd graders' ability to spell. So the ability to spell. Well, okay, there's some practice in identifying dependent and independent variables. Again, another important concept for you. It'll make you much better consumers of research if you are able to distinguish these when you're reading research articles. Okay, now we're going to take a look at the concepts of validity. The concepts of validity. Now, it's important that research, good research, or let me say this, for good research to be usable, it has to be valid. And in terms of validity, in terms of research, there are two types. There is what is called internal validity, which you see on your screen now. If a research study has strong internal validity, we can say with a high degree of probability that it is the independent variable or the treatment or the intervention strategy and the independent variable alone that was the cause of the change in the dependent variable or the behavior being measured. So if research has very good internal validity, in other words, the researchers have controlled for a lot of threats to internal validity, then we can say with a high degree of probability that the change in the dependent variable was due to the intervention or the independent variable. If the internal validity of a piece of research is poor, then there may be some confounding or extraneous variables that have caused the observed change in the dependent variable of behavior, and therefore we really cannot trust the results of that research. So internal validity is important for a piece of research. It's important. Now the other type of validity is called external validity. Now, researchers are usually interested in developing strategies that will affect an entire population of some kind. Now, this is not the total population of the world or something like that, but a population that they're interested in. And usually populations are way too big to be able to study all of it. So they'll draw a sample from that population. So they'll take a sample from the population and they'll study the sample, with the idea that they would like to be able to generalize back to the population. So a research study has strong external validity when the results of the study can be generalized from the sample that was under study to the population that the sample was drawn from. So if a piece of research has strong external validity, in other words, the researchers have controlled for the threats to external validity, then we can, with confidence, we can generalize from the sample that the researchers studied to the population that the researchers drew the sample from. And the better the ability to generalize, the stronger the external validity. Well, okay, so that's internal and external validity. Now we are going to take a look at different types of internal and external validity. All research, even the best of the best, has certain threats to its validity, to its internal and external validity. And over the course of the last 100 years or so, researchers have identified certain threats to internal validity and external validity that seem to frequently crop up over and over again. If these threats to the validity of the study are not dealt with, they can seriously affect the results of the study. Now, for you to be a competent consumer of research, it's important that you're aware of these standard threats to validity so you can critically analyze the research that you'll be reading. On the screen in front of you are 8 standard threats to internal validity of a research study. And keep in mind, if a study has good internal validity, we can be confident that the results can be trusted. And we can say with a high degree of probability that it was the independent variable or the treatment that caused the change. Okay, the first threat then that you see on the top on the left side of your screen is history or a historical threat. Now, history or historical threats to internal validity refer to events that take place during the length or history of the research project, but they're not part of the experimental treatment. They are environmental things that happen while the research study was going on. And you can see you have someone with the flu, so the group that's being studied, a bunch of people may get the flu, or how about 9/11, atom bombs? Those are silly. But anything that happens during the history, during the length of the research study, that is outside of the treatment can be a historical threat. And in terms of history as a threat, generally, the longer a research study lasts, the greater the possibility of something happening during the course of the study that will affect the results of the study and therefore cause a historical threat. Now, the second threat here is maturation. Now, maturation refers to natural, physical, or intellectual or emotional changes that occur to participants over the length of the research study. Now, history referred to environmental changes during the length of the research study, whereas maturation refers to internal changes within the participants during the research process. And these internal changes may affect participants' performance. And so you can see the video, the graphics there. They may become more coordinated. They may become more anxious, just bored. They may become more mature. There's all kinds of things that could happen to participants during a research study that can present threats, and they're referred to as maturational. Now, you'll see on the bottom it says maturation may be more likely to become a threat when the participants in the study are very young, because younger people tend to go through more rapid physical changes. Picture a sixth grade classroom and the changes, the emotional and physical changes that go in the course of 1 year. Quite a few changes. All right, our next threat is referred to as testing. And generally, this is a threat when you have a pre-test and post-test. So testing or pre-test sensitization refers to improved post-test scores as a result of taking a pre-test. Taking a pre-test may improve post-test scores even if no intervention takes place in between. You could give a pre-test, just wait a while and have everything normal, wait several weeks and give a post-test, and students may score better on the post-test just because they took the pre-test. And testing is more likely to present a threat to internal validity when the time between testing is short. If there's a long, let's say it's an entire semester between pre and post-test, well, that's a fairly long time. So it'll probably nullify any pre-test effects. But if it were short, like a 2-week period between pre-test and post-test, then taking the pre-test may affect and may present a testing threat. Also, testing may present a greater threat with studies that measure factual information that can be recalled fairly easily. Okay, so the next threat then is instrumentation. And instrumentation refers to the unreliability or the lack of consistency in measuring instruments, and that can result in invalid assessment of performance. Examples are unequal pre- and post-tests. That could present a real instrumentation threat to internal validity because the instruments are different, or poorly constructed surveys. The measuring so some examples, the measuring instrument could be changed, so that's like unequal pre- and post-tests. A single measuring instrument is unreliable. Now, I've mentioned I did my doctoral dissertation creating a piece of software and then a remote control recording device that allowed the user to walk around a classroom and collect direct observational data just by having a thing about the size of a credit card and clicking, and it would automatically send it to the computer. But that's not the point. When it came time to validate the software and this remote control instrument, I did a study at a school for autism in Princeton, New Jersey. And about 8 practitioners were using the software and the remote control, but one was getting extremely, extremely erratic readings. And we couldn't figure it out. Something was wrong. And what we figured it out was that she had put the remote control device on a heater, on a radiator, and that interfered with the signal. So that was an instrumentation threat because the measuring instrument was unreliable. And another instrumentation threat is many times there'll be some people doing direct observation, collecting data over the course of a research study, maybe sitting in a classroom and doing observations and collecting data. And the tendency is for the data collectors to drift a little bit, And so there becomes a discrepancy between when they started collecting data at the beginning of the research study, and then they got a little sloppier as it went along and along. So that can be an instrumentation threat also. The next threat we'll look at is statistical regression. And statistical regression usually presents a threat to internal validity when participants are selected for a study who score extremely high or extremely low on some kind of a test, on a pretest. And then on the post-test, the scores will have a tendency to regress back to the mean. So you could have an intervention, and then you could give a test to see if the intervention worked. And some people maybe got lucky and got really, really high scores. But those scores may not be really indicative of what their normal score would be. And if they took the test again, their score would probably move back towards the mean. And that's called regression or statistical regression. Scores have a tendency to move back towards the mean. Next threat we have is differential selection. And differential selection presents a threat to internal validity when participants in the experimental and control groups have different characteristics that affect the independent variable differently. This occurs a lot when researchers are forced to use intact groups like classrooms. When they're compared, because the groups may be different. You might have one group that has a lot of high-functioning students in it and another group that has low-ability students in it. And so the groups are not equal. And this can present a differential selection threat. This is very common in quasi-experimental research designs, which you'll hear about later. Okay, now let's take a look at mortality as a threat. Mortality, or attrition, occurs when different participants drop out of a study in different numbers, altering the composition of the treatment and control groups. And the changing characteristics of the groups can significantly affect the results of the study. It's possible that participants who drop out of a study may be less interested in the study or less motivated to participate than those who remain. And so you wind up in that case with a whole bunch of people who are really, really eager for this study to go well. And so the study does go well, but it's not representative. The sample has been diluted somewhat. That's referred to as mortality or attrition. And finally, we'll take a look at selection, maturation, interaction. Now, this may occur if participants selected into treatment groups have different maturational rates. So it might be age differences, maturity differences. and therefore it makes the groups non-equivalent. That is a selection maturational effect. Well, okay. Now, pardon me, here you have 8 statements, and each one pertains to one of the threats to internal validity. So I'd like you to put the video on pause and see if you can match up each of those statements with the threat to internal validity. And then when you're done, turn the video back on, and then we'll go over the responses. Okay, let's take a look at number 1. When existing groups are used in a study, one group may benefit from a treatment, because of changes that may have taken place in participants in that group. So changes may have taken place in participants in that group. So that would be selection maturational interaction. Pardon me. Selection maturational interaction. Let's take a look at number 2. Participants who scored high on the pretest will tend to score lower on the post-test. Well, that's statistical regression. Scores will tend, if they're extremely high or extremely low, they'll tend to move towards the mean. That's the threat of statistical regression. Number 3, something happened during the experiment that influences the performances of the participants. Well, if something happened during the experiment, that's most likely a historical threat. A historical threat. Number 4, an unreliable measurement instrument was used in the experiment, and that would be the threat of instrumentation. Number 5, pre-test scores influence post-test scores. That would be a testing threat. Pre-test scores influence post-test, that's testing. Number 6, a physical change in participants has taken place during the course of the experiment. That would be a maturational threat. Number 7, several participants in the control group dropped out of the experiment. That would be mortality or attrition. And finally, the control group and experimental group are not equivalent in the variable being measured. And that would be differential selection of participants. Okay, now on to threats to external validity, or the ability to generalize. Just like there are the standardized threats to internal validity of research studies, there are also standardized threats that have been identified to the external validity of research studies. And as a review, if a research study has good external validity, we can be fairly confident that the results can be generalized back to the population from which the sample was drawn. So suppose we wanted to study the effects of a certain program on a population, let's say all 11th graders in California. Well, the population is way too large to study everyone, all the 11th graders. And so we draw a sample from that population. And we conduct a study on the sample to see how this program works out. And so we conduct the study, and we find that the study has good internal validity, which allows us to say with a lot of confidence that the program was effective in causing a change in the behavior of the sample participants. And also it turns out that the study had strong external validity. Well, then this allows us to say with confidence that not only did the study produce a change in the sample, but the results of the study then can be generalized back. And that's external validity. And here are some threats to external validity. We have pre-test treatment interaction. And by the way, don't get bogged down in all of these terms. It's not really important that you memorize all of these terms. It's the concepts that you need to be aware of. You don't, like you may not remember pretest treatment interaction, but you may remember that there may be times when a pretest may sensitize participants to aspects of a treatment and therefore influence post-test scores. So the concept is important. Name, don't get bogged down in that. And in some studies, the potential interactive effect of a pretest is a more serious consideration than others. As an example, the longer the length of the research study, the less possible interactive effects of the pretest. And we've already talked about that. If it's a short time between pretest, then it may present a bigger threat. Okay, so that's the pretest treatment interaction. Now we have selection treatment interaction. Use of non-random or volunteer selection of participants limits generalizability of the study because the sample may not be representative of the population it was drawn from. Suppose a researcher were to conduct a study on the effectiveness of microcomputer-assisted instruction on math achievement of junior high students. Now, the classes available to the researcher, the accessible populations, the researcher was forced to use classes. So entire classes may represent lower ability level than average junior high school students. And therefore, it's not representative. So this study wouldn't work. So again, the point is this: if the group selected is not representative of the population that it's going to try to be generalized to, then that is a real threat. And that's selection treatment interaction. We have multiple treatment interference. When participants receive more than one treatment, the effect of prior treatment can affect or interact with later treatments, and that can limit the ability to generalize. So suppose we had a study, lasts 2 months, and it successfully employed positive reinforcement to reduce acting out behaviors in a classroom, let's say. Then in the next 2 months, the same participants were exposed to a second treatment, which was aversive consequences. So if they acted out, they got hand slapped, spankings, or whatever. At the end of the second 2 months, acting out behaviors was less than when positive reinforcement was used. So the question is, can we conclude that the punishment, the adverse consequences, the punishment was more effective than positive reinforcement? Well, not so, because it could be that the combination of the two treatments together, the positive reinforcement may have started to lower acting out behavior, and then the adverse consequences may have lowered it some more, or the positive reinforcement may have brought the behavior way down, and the adverse consequences may have come up a little bit, but in the overall, it still was down. So we have to really be careful. So that's multiple treatment. When multiple treatments are used, that can present some interference. There is a diffusion threat, where treatment groups communicate and adopt pieces of each other's treatment, and that alters the initial status of the treatments being compared. And you can read this: knowledge of each other's treatments often leads to groups borrowing aspects of each other so that the study no longer has two distinct different groups, but two overlapping groups. If you could picture like a Venn diagram of two circles and part of them overlapping. That's a diffusion effect. Can be an experimenter effect. No. This is pretty typical. Conscious or unconscious actions of the researcher affects participants' performance and responses. And this was the horse that could count, but it was actually the caretaker of the horse that was giving the horse cues. But I'm not aware if you're aware of the brouhaha that went on about facilitative communication and individuals with autism. That was one where researchers or participants actually influenced the performers, and it presented an experiment effect as a threat. And the other threat is then reactive arrangements. The fact of being in a study may affect participants from their normal behavior. The Hawthorne effect. This was an industrial psychology study done, I'm going to say in the 60s, but I'm not quite sure. But anyway, and I don't know where Hawthorne is or what the company was, but I know it had to do with lighting. And they were looking for the optimal lighting, and so they kept adjusting the lighting and were keeping track of how their workers performed, how they produced products. And the workers were aware, and so no matter what they did with the lighting, made it really, really bright or really, really dark, they kept improving and improving. And that's referred to as the Hawthorne effect, just being involved in an experiment, or the John Henry effect. And that's another example. I'm sure you're familiar with John Henry. Well, okay, so you have reactive arrangement. You can read the rest of the reactive arrangements. And these are the standardized threats to external validity. Well, here you go. You have 6 statements, each one representing a threat to external validity, and then you have the external validity right up above the statement. So put the video on pause and try and figure out which threat to external validity matches up with which statement. Then turn the video back on and then we'll go over them. Okay? Okay. So number 9, the pretest sensitizes participants to certain aspects of the treatment. And that would be A, pretest treatment interaction. Number 10 is the John Henry effect and the Hawthorne effect. And that would be F, reactive effects or reactive arrangements. Number 11, non-random or volunteer selection of participants limits the generalizability of the study. And that would be selection, treatment, interaction. Number 12, conscious or unconscious actions of the researcher affects participants' performance. And that would be E, experimenter effects. 13, participants receive more than one treatment that affects their performance. And that's C, multiple treatment interference. And 14, treatment groups communicate during the study, and this affects their performance. And that would be D, treatment diffusion. Well, okay. So let's do a quick review here. The results of an experiment can be considered valid if 2 conditions are met. If we can say with a high degree of probability that the obtained results or the change in the dependent variable is due to the application of the independent variable, the intervention or the treatment. That's one condition that needs to be met. And you know that as internal validity. So if the research has internal validity, and the second one is the obtained results can be generalized to the population from which the study sample was drawn, and the study can be replicated, and that is external validity. So the results of an experiment can be considered valid if it has very good internal validity and very good external validity. And the way you can judge that is by being aware of the threats to internal validity and the threats to external validity. And they can be considered extraneous or confounding variables, variables that allow for alternative explanations of a research study. Well, okay, so just to review, we've gone over independent variable, which is a treatment or intervention, dependent variable, which is what the researchers are measuring, what they're trying to change. We talked about extraneous or confounding variables, and those are variables that present threats to the internal and or external validity of a study. And then we looked at the standard threats to internal validity and the standard threats to external validity. And again, I just want to emphasize that the names of all of those standard threats are not as important as the ideas. If you understand the principles, then you'll be able to critically read and analyze research articles. Okay, thank you for your time and consideration. If you're interested in the resources that were used in putting this video together, there they are. And we'll see you next time. Thank you.